You're about to build your first AI model, and it takes less than 15 lines of code. No GPU, no paid tools. We'll teach a computer to recognize clothing from images and reach over 90% accuracy. Let's get started.
Every machine learning project follows the same pipeline. First, load your data, then explore it so you understand what you're working with. Next, build a neural network. Train it on thousands of images. And finally, predict on new ones. 5 steps, end to end.
Where should we run our code? There are 2 options. Your own machine, where you installed TensorFlow in the last video, or Google Colab, a free notebook in your browser. Colab comes with TensorFlow pre-installed and even offers a free GPU. For this video, we'll use Google Colab.
Open colab.research.google.com and create a new notebook. A notebook is just a stack of cells. Click the play button to run a cell, and the output appears right below. One more trick. Open the runtime menu, choose Change Runtime Type, and select T4 GPU.
It's free, and it makes training much faster.
First, import TensorFlow, NumPy, and Matplotlib. Then check the version. It prints 2.21.0. That's TensorFlow with Keras 3 inside. And remember, Colab already has everything installed. The exact same code runs on your own machine, too.
Now, load the Fashion MNIST dataset. Keras downloads it for you the first time about 30 megabytes and caches it after that. The data is ready when the download finishes. 60,000 training images, 10,000 test images, all 28 by 28 pixels.
Let's explore the data. The training set has 60,000 images, each 28 by 28 pixels. There are 10 clothing classes, from t-shirts to ankle boots. The class names aren't included, so we define them ourselves. Then we plot 25 sample images.
You can see sneakers, dresses, bags, and more.
Before training, we normalize the pixels. Every pixel is a number from 0 to 255. We divide everything by 255, so all values land between 0 and 1. 0 is black, 1 is white. Smaller, consistent numbers help the network learn faster and more stably.
Now we build the neural network. The first layer flattens each 28 by 28 image into 784 numbers. Then a dense layer with 128 neurons learns patterns. The final layer outputs 10 scores, 1 per clothing class.
3 layers, and that's the whole model.
Before training, we compile the model. The optimizer is Adam, the modern default. The loss function is sparse categorical cross-entropy, which fits integer labels from 0 to 9. And we track accuracy as our metric. Now the model is ready to learn.
Time to train. We fit the model for 10 epochs, meaning it sees the full dataset 10 times. Watch the loss drop and the accuracy climb. By epoch 10, the model hits about 91% on the training data.
But the real test comes next, on images it has never seen.
Now we evaluate on the test set, 10,000 brand new images. The model reaches about 89% accuracy. Notice the small gap, 91% on training, 89% on test. That gap is called overfitting when the model memorizes training noise instead of learning general patterns.
Finally, predictions. We add a softmax layer, which turns scores into probabilities that sum to 100%. For this image, the model is 98% confident it's an ankle boot. In a grid of 15 test images, 13 are classified correctly. Even AI makes mistakes sometimes.
If you hit an error, here are the 3 most common fixes. Shape mismatch means your data and model don't agree, so keep the input shape aligned. If you see shapes incompatible, you're probably using the wrong loss for integer labels.
And if matplotlib is missing, install it with pip, then restart the kernel.
That's the whole pipeline. You loaded 60,000 images, built a 3-layer network, trained it, and reached 89% accuracy on new data. In the next episode, we'll make it smarter with convolutional layers and run it on your phone. Like, subscribe, and comment. Happy machine learning!